So today's topic is about zero force member. And in trust, sometimes a member have no tension or compression. In that situation, that member will basically bear no nodes, right? So in that situation, it's going to be zero force member. There's no magnitude of force on there. That member is there just for rigidity, right? But sometimes think about if a truss have a different external loading and there may be some loads on that member. But for today's topic, we're just going to look at how do we identify those zero force members. Sometimes it's very helpful to do that. Now let's look at the typical two ways when zero force member occur. The first possibly occurs is when you have two members are connected in lines, like for example AB and BC that pinned at C here. This is part of the truss here. And then if there's going to be another force that's coming at point B here, though actually this is not going to be another force, another member coming at point B, okay? And if we call that BD, and this BD is going to be the zero force member. It's zero force member. Why so? Let's try to prove it. We learned from truss is actually axial member. If it's an axial member, which means it's going to be along the axis, right? So if we were using massive joints to look at point B, so if we look at point B here, joint B, then what do we have? We cut off AB and BC and BD. So if we assume BC is going pulling that direction and AB is pulling that direction, so that's our BC. This is our AB. Then also it's axial member BD if we assume it's pushing in there, okay? So those are the three forces acting on our joint B, and they have to be balance each other, right? Traditionally, we do some forces at X and Y, and again, one have to be flexible. Can we just make maybe potentially, for example, this as our X direction? And if that's the situation, this is going to be our Y direction, right? I call X prime and Y prime. So if I do summations of fx prime, what do we have? I'll have BC to the right, AB minus AB. Then this BD will have X prime component, right? Because if I decompose, that's going to be X prime and Y prime. So if we consider that's alpha, so we'll have BD times cosine alpha. Well, that equal to 0, right? Then now let's look at summation of force at Y. What do we have? BC and AB lies perfectly on X prime, and so BD is only force that has Y prime component right here. And that's going to be our BD times sine alpha equal to 0. Since there's no other forces at Y prime, BD have to be equal to 0. Correct? If BD equal to 0, bring up to the X prime equation, that's 0. Then what do we get from here? AB equal to BC, but that's not the point. But what's the point here is BD has to be the zero force member here. We do not need to prove this every single time. From this example, what we learned is what we can generate the pattern. The trick is if you have two members, AB and BC, that is, it comes to a joint, right? They are linear, they are coming to a joint. Then you have another force here, BD, come to, coming with an angle, to them. Then this force have to be zero force member. Okay. Now, the second scenario we could potentially see when it is zero force member is when you have this overhang. What I mean overhang means they are not supported by anything. For example, this is our A and this is our B and the AC. That pinned at A. Then here we can immediately say the trick is those AC and AB both are zero force member. AC, AB both equal to zero. Why so? We can again prove it. If we do forces at x direction, we'll have AB. If we're going to actually draw the joint, right? So if we look at the joint A, here I'm going to go ahead and write down my FBD. This is joint A. If I circle it, I'm going to cut AC. If I assume AC is pushing A and AB is pulling to this direction. That's my FBD for this joint A. Then what do we have? Our force is at x direction. We'll have AB. And AC, if we assume this is angle alpha, so AC times the sine alpha, negative, that equal to 0. We also forces at y. Since AB is on the x direction only, the y direction will have negative AC times cosine alpha equal to 0. From here, again, what do we calculate? AC have to be 0. So AC is a zero force member. If AC is 0, what do we get for AB? AB has to be 0 as well. So that proves our point. So in the future, we can learn if you have two members that's just going to be connected, like overhang, which means not supported by anything. What I mean supported, not supported, is like, for example, if you have AC and AB. However, right now, if A is supported on a pin support or roller support, that does not work anymore. AC and AB is no longer zero force member. AB and AC is no longer equal to 0. Okay? However, if there's no support, if we just no support, then both of them are going to be zero force member. So those are the common way when zero force member coming up. So thinking about the first possibility and also the second possibility here. Now I'm going to practice with you how we're going to use those rules to like select a zero force member, right? Now let's look at this example here. Can you find any zero force member in this truss here? Let's see. There are many situations like 1, right? Rule number 1, for example, my CD and the DE, they joint at D, and the DF comes in an angle to that joint D. So what do we know? DF has to be a zero force member. So that's the first one in there. Any other possible zero force member? Okay. Then what else do we have? Then how about, is BG, this one, a zero force member? You said, okay, AB and BC join at B, and BG come as an angle. However, there is external force here, okay? So if you have external force, it's no longer the perfect example for 1. Perfect example for 1 is when you have two members connected at B and there's another force come as an angle to this joint. However, there's no other forces at point B. So for example, if I'm going to draw something like that, if you have AB and a BC, join at C, and then you have a BD that comes to this joint, and however, this situation I have external force here, then this time your BD is no longer a zero force member. Okay. So BG here, be sure BG is not zero force member. All right, now let's continue to look at it. If DF is zero force member, how about looking at this? GF and FE comes to and join to F. And even though there's a CF and also DF, remember perfect example is only one member. For example, BD come to joint right here. But what do we notice? This DF is a zero force member already. So basically you can ignore this DF. What do you have only is CF. CF have to be zero force member. So another exception, I'm going to write it down for you here. Yes, if you have AB and BC joined at B, and however you have several other members, for example, you have BD and you might have BE. In that situation, BD and BE, they are no longer zero force member. It's very picky. The picky way is have to be the only one member comes in and there's no other forces acting on this joint and only one member, then that one member will be zero force member right here. Okay? So for this example, we have DF and CF, both are zero force member. No, then any others? Then you might say, how about B? How about CG? Is CG one? It's the AG and the GF connected at G. That's our pin. However, BG and the CG both come to the joint G, and the BG is not zero force member, so CG will not to be the zero force member. Okay, so for this example, you got CF and DF. Hopefully you're having fun. Now let's look at this example. This example, do you see any overhand? Overhand like the presentation we had for 2 here, right? AB and AH are overhand, and there's no support. Perfect example, both of them are zero force member. How about this one? EF and DE, that overhand, and there's no support, but what happens? There's also external force. So maybe here I'm going to go ahead and write it down, another restriction, no support, and there'll have to be no force, external force. In saturation, then they both will be zero. But when you have a force here, they are no longer zero force member. Okay? Now let's take a look then. How about BC and the CD connected to C, and the CG is only for member that's come to the pin C. That's perfect example for 1. So that's going to be CG as our zero force member. Now any other ones there? For example, you can look at GH and FG connected at G, but now you have BG, DG, CG all coming there. Even despite CG is 0, but you still have two other member coming, BG and DG, so they are not zero force member. Okay. And how about, let's look at GF right here and EF connected at pin F. DF comes in now, right? DF is the only member comes in. However, what do we have? You have a support at E, so that wouldn't work. Okay, so here it's so picky. I'm going to write it down. Have to be no external force, no support, and also have to be no just one member comes in and angle. With all those satisfied, then that member is zero force member. Okay, now continue. Let's look at example 3 here. What do we have? Immediately you can look at it. AB and BC comes to B, and BJ is only member that comes in, and there's no external force, no support, so BJ is zero force member. Same thing. DE and EF comes to E. EH is the only member comes into that joint, no external force, no support, that's going to be zero force member. How about EF when the FG comes to at F and FG comes in, only member comes in, that's going to be zero force member. Now, if those two comes in, let's say JH and HG joined at H, and those two, EH and FH, both zero force member, so DH considered as only one member that comes to joined at H, right? Because they are EH and FH is zero, so that's have to be zero force member as well. So can you believe that all those three are going to be zero force member? Now let's look at this. AJ and JH connect at J. BJ is zero force member, but you have CJ and DJ. There are two members comes in, so they are not zero force member. We have to have just one comes in. Just one member comes in. Okay, so let's move to example 4. Any zero force member here? Let's take a look. AH and HG comes at point H, and the BH comes in as only a member, no external support, no external loading, so BH have to be zero force member. Anything else like that? And you might say, okay, how about AB and BC comes in at B, and since BH is a zero force member, BG will be, but the answer would be wrong because you have what? External force right here. This external force right there. Then how about CD and D comes to a joint D, and GD and DF, the two members comes in an angle, so they are not a zero force member. So now let's look at GF and EF. They come to a F, and despite DF is the only member that comes in, but there's what? External force. So DF is not zero force member. So for example 4, BH is only one here that is zero force member. All right, hopefully this is useful because finding zero force member can be quite helpful when you're solving a problem. And I might do some examples on that in the next video. See you next time. Bye.